Okay.
All right, let's look at objective 110. Now, we talked about objective 108 yesterday, and the main concept between 108 was, if I'm taking two things and multiplying them, and they get to be 0, then what can you decide? One of them is 0. So if I'm like remember yesterday I said, hey, if a smiley face times a football is 0, then either the smiley face is 0 or the football is 0. So that's what the concept is. Like, this is what we looked at yesterday. Instead of like multiplying two things, though, those things are this binomial and that binomial. It's still just two things. It's this thing times that thing. So if I multiply this thing times that thing and get 0, either this one is 0 or that's 0. So this is just that concept we talked about yesterday. So you set them each equal to 0. So then over here, set 3x plus 6 equals 0. Maybe that's what's getting me the 0. Or maybe it's x minus 4. So you set x minus 4 equal to 0. So you make this two little mini equations.
Okay.
Work this out. So let's minus the 6 over. And you got 3x is negative 6. And x is negative 2. And then x is negative 2. So one of your possible answers, as Brian said, is negative 2. The other one, just move the 4 over and you get 4. So that's all review from yesterday. What you're going to see today is that the left side of your equation is not going to be two binomials. The left side of your equation is going to be a trinomial. All right, so as with many things that you're going to do in mathematics, there are several different ways to solve what we call a quadratic equation. This is just going to be the first of several. And by several, I mean, really there's about like 3. This is the first way. Now, this thing right here, I called it a quadratic equation. I need your brain to realize and tell me, why did I call it a quadratic equation? Because it has an x squared, and then that's the quadratic part of it, and there's an equal sign. This is an algebra thing with an equal sign, so that's what makes it an equation. And because it has x squared, it's a quadratic equation. Now let's just focus on the left side. You got the right side equals 0. That's kind of like the problem on the first page where you had the right side equals 0. What we want to do with the left side is take this trinomial and unfoil it like we were doing last week. Let's unfoil it into two binomials. Let's get back to where this is what you got. So remember about factoring. If you do not have a coefficient right here, it's not that hard. First thing is you want to drop what right here and here? X's. If you're unfoiling this, that x squared came from x and x. That's the process, x and x. Now I want two numbers, the numbers that go here and here. They need to multiply to what? 4 is something else. They need to multiply to negative 5, and then they're going to add or subtract 2, 4. So I'm going to go right over here, and there's only so many ways to get 5. It's got to be 5 and 1 somehow. If I want a positive 4, what should I put in here? Negative 1 plus 5, or positive 5 minus 1, either way. We'll go with what you said. You said negative 1 plus 5. There it is. So step 1 in solving a quadratic is first realizing it's a quadratic and then going, okay, I can unfoil this into these binomials. Then you're looking at what we had yesterday, and you guys said that was so easy. Set this equal to 0, and you're going to get what?
1.
X equals 1. Set this equal to 0, and you're going to get? So there's your answers, 1 and negative 5. The only difference between this and that is that you had to take the trinomial and get it into the two binomials.
It's huge.
I can zoom it up for you a little bit here.
Thank you.
Okay, we're getting ready to look at this next one. It says try. We're going to work it together, though. So a few questions about it. First off, tell me what you're looking at when you see this. Quadratic equation. And the left side is a trinomial. So what do I want to do with that? Put it, unfoil it into what?
A binomial.
A couple of them, two of them.
Two binomials.
That's what I want to do. I don't want it to be like a trinomial. I want two binomials because then I can set each one equal to 0. Now, there is no coefficient here, thankfully. So what goes in those parentheses first? X and X. I need to multiply to what? Right. So there's a few ways to get 24. 24 and 1, 12 and 2, what else? 3 and 8, and one more. 4 and 6. So those are your options.
3 and 8.
3 and 8. Okay, so 3 and 8. But if you want to make negative 11 out of that, what needs to go in? Negative 3 minus 8. Negative 3, negative 8. There it is. Those are the numbers. These two numbers add or subtract to negative 11. And if you multiply them, you get positive 24. Now that you're at this situation, what are we going to do? Yeah, so x equals 3, and then x equals 8. There's your two answers. X equals 3, and then x equals 8. And this one, I like this one. I use this all the time when I'm showing how to factor it first. X squared plus 5x plus 6. Let's put the left side into two binomials, drop your x's in, and give me the numbers that if you multiply, you get 6. But if you add, you get 5.
3 and 2.
3 and 2. Just positive 3 and positive 2. So put plus 3, plus 2. Plus 3, plus 2. Doesn't matter. You could have said plus 2, plus 3. You're going to get the same two answers. Remember, x plus 3, you set that equal to 0. I'll go ahead and do it this time. And then x plus 2, set that equal to 0. This ends up giving you x equals
Negative 3.
negative 3.
That's x equals
X equals negative 2. So there's your two answers. The reason that you get two answers, by the way, is because those, if you took negative 3 and you put it into these x's, the left side would be 0. If you took negative 2 and put it into these x's, left side would be 0. Tyler?
Would it be possible to use negative 1 and positive 6?
That's a good question. The one problem with that, and you got to be careful for that negative, what do you say, negative 6?
Negative 1 and positive 6?
Yeah. There will be a time when those will be the right numbers, but x minus 1 and x plus 6,
Yeah.
those definitely add, but negative 1 and 6 definitely gives you 5, but negative 1 times 6 doesn't give you the positive 6 you need.
Okay.
So, but if this was negative right here, that is the answer. So say that was negative instead of.
Okay. If you okay.
Yeah. So there will be a time when negative 6 or negative 1 and 6 is the answer. We just haven't got there yet. All right. Example number 2. This is what I'm looking at. Now, first off, tell me some things that you know about this. It's quadratic for sure. It's got x squared. It's for sure it's quadratic.
An equation.
It's for sure an equation.
binomial on the right.
Yeah, it's got a binomial on the right and an x squared on the left.
It's an equation.
It's an equation for sure. It's quadratic for sure. Here's what you want to do though. We want that equals 0, like what we had yesterday. We had the two binomials equal to 0. Like what you had on the other page where you had this trinomial equal to 0. So the first thing that we do, if it's given to you like this, you go, man, that's quadratic. Move all the pieces over to the left so that we can have x squared, then you'll have minus 9x plus 20 equals 0. Move all the pieces. It's quadratic. The first thing you want to do is, there's only 3 types of pieces in a quadratic equation. The x squared piece, the x piece, and the number piece. Even if you have like 15 different pieces, there's only 3 types. So you can move them all over to one side, and then you should only have 3. So move the 9x over. So I move the 9x over, and add the 20 over. Now I'm taking everything off the right side, so I leave the right side equals 0, and I actually have x squared minus 9x plus 20 equals 0. So the first thing is, if the pieces are on the left and the right, get them all over to the one side. It doesn't matter if you get them all over left or right. Just get them over on one side. And then, let's work this. Now you got that trinomial on the left. Factor it, which means unfoil it, into two binomials. I need the numbers that multiply to 20, yet if I add them or subtract them somehow, I get -9.
Negative 5.
-4 and -5. -4 and -5. So if I said -4, -4 and -5 add together and make -9, -4 and -5 multiply and give you that plus 20. That's it. Then set this equal to 0, and that's going to give you what answer? X equals
4, X equals 5.
And x equals 5. So that's the first time that the original problem was jumbled up. It's quadratic, but I call that jumbled. It's like the pieces aren't all on the same side, so just get them on the same side. Now you got the same situation here. Tell me what we're looking at though. What is that? What do you know? What do you know about it? It's quadratic. I heard equation. The one difference is there's how many pieces? Total. 2. Instead of 3, there's only 2. It doesn't matter. We're still just going to move everything over to the one side. This one says move x squared to the left, so let's just follow the instructions I got. Let's move this x squared over there to the left. So minus x squared, minus x squared. That makes your right side 0. So you got negative x squared plus 121x equals 0. Kill the light. All right, one note. I'm gonna scoot over here and look at the one note right here. This says we don't want the leading term negative. Most often, you don't want your x squared piece to be negative, and there's an easy way to fix it. Just like you've learned before, multiply everything by -1, and that'll fix it. So we don't want negative x squared. I don't mind if this one's negative. I don't want this one negative. So multiply everything by -1. Here, here, and even -1 times 0. And you really get x squared, yeah, -0. X squared minus 121x. And -0 if you want to call it -0. I only do that because I personally don't want to deal with a negative x squared piece. You might like it, I don't know. Now tell me what you're looking at. It's still quadratic, right? It's still an equation, but there's not 3 pieces over here. So here's the deal. If it's not a trinomial, like Hunter pointed out, we had a trinomial. If it's not a trinomial, you're not going to unfoil it. But there is something that you can do. You can undistribute. Both of these pieces have the letter x on them. So if I undistribute an x and put it outside of a parenthesis, I can put an x right here. And if I took an x off an x squared, it leaves me with just x. If I took an x off of my 121, I just get minus 121. Exactly. So I have 2 pieces. I don't have a trinomial. I'm not going to unfoil it. What I'm going to do is go, is there something I can undistribute, something I can take off of it? If it's an x, great. Take one of these x's off and take that x off. If you re-multiply this, does this give you x squared?
Yes.
And does this give you minus 121x? So that's what we're doing. We're just undistributing. And now you're back to where we were yesterday. You're not multiplying 2 binomials, but you are multiplying this one monomial and this one binomial. So set each thing equal to 0. Set this equal to 0, and then x is 0. That's one answer. X is 0. Set this equal to 0, and x is what? 121. Just like that. Okay, so this time we didn't have a trinomial on the left, so I just pulled an x off of each piece. And we're going to still, since this is new, we'll try these together. Just tell me. First thing, you're looking at a quadratic equation. This is the type that doesn't have all 3 pieces. So what should we do? What did I do last time? Get everything left. Get everything left. So what are we going to minus on each side? And I got x squared minus 2x equals 0. Do you have a trinomial on the left? On the left? No. So you're not going to unfoil. But is there something you can undistribute? Yeah, you can take an x off those pieces. So how do I do it? What do I write?
Put a X and then
Come on.
parentheses.
Then a parenthesis. This would turn into what?
X.
Just x. This turns into
Negative 2.
just like that. If I redistributed, this is x squared and this is minus 2x. Now here's your two things. You're multiplying that x outside times that parenthesis, that binomial inside. If you're multiplying two things, then they get 0. Set them each equal to 0. What does this give you? X is 0 is one answer. What's the binomial give you? X equals positive 2. X equals positive 2. And remember, if you took this and said x minus 2 equals 0, you add that over and you get x equals 2. I'll leave that for a second, then we'll come down. All right, the next one. So some of you finishing up the last one. The next one, still a quadratic, still equation. How do you want to do it?
Move the x squared.
Let's move the x squared to the right. Since everything's kind of over on the right, let's just take that negative x squared, and if you move it to the right, it becomes positive x squared. Just put it at the front. Put it as the first thing. So Emily has the right idea. Let's just move the one piece instead of having to move the two pieces. And since it's negative and we don't want a negative, that'll kind of help that. So here's 0 equals. When it comes to writing this right side, put the x squared first. So go x squared, 4x, 12. X squared, 4x, 12. Zoom in on that. Of course, it disappears. Okay, what are we going to do next? Yeah, unfoil. Put parentheses right below it, so instead of the trinomial, hopefully we can get it to squeeze into a couple binomials. We need two numbers that multiply to 12. So that's not too bad. 12 and 1, 6 and 2, 34. 6 and 2. This one does not look good, does it?
No.
It's gonna have to be a negative.
Yeah, that's not. It's not gonna work.
Yeah, it's not gonna work. It is true. So we won't be able to factor it.
That'll just be no solution.
Well, we're just not going to be able to solve it with factoring, that's for sure.
Why would you do this?
I know. What would have been better is if I said negative 12. Negative 12.
Yeah, can we just change it?
Yeah, let's just say it's negative 12. We are going to learn how to do it when you can't factor it, but let's just say it was negative 12. And then let's cut this out of the video when we post it online.
Nah, no need, we're good.
Okay. All right, so let's pretend it was negative 12 all along. Can I multiply to negative 12? Yes. I'm going to go negative 2 plus 6. Negative 2 plus 6. There we go. Now I'm in business. And as we get further along, you will learn how to actually solve it when you can't factor it. So what's my two answers? X equals what? 2 and negative 6. After we kind of like change the problem. Lastly, I got be ambitious down here because what's the one difference between this quadratic equation and the previous page's worth of it?
The coefficient on the x squared.
Coefficient on the x squared. That is what makes it tough. That's why I said use Berry method, because of that coefficient. So you've got to recall the Berry method, which we learned last week. If you have a coefficient on the x squared, that kind of sucks, because that makes it way harder. But the process is, what are we going to put in here?
8x.
8x and 8x, which is not right. If I put 8x and 8x in, I will have to fix it later, because that makes 64x squared. I'll fix it later. I need two numbers that multiply to, and you connect this and this, multiply to 8. So the only ways to get to 8 are 8 and 1, 2 and 4. Choose the pair that will give me 6. So put a 2 and 4 in there. Plus 2, plus 4. Now Berry method says, if you can reduce you reduce, and then just throw that number out. So this can be reduced by what? 2. This can be 4x plus 1. So if I pull the 2 out, that becomes 4x plus 1, and then you just kind of throw that 2 off. What can I reduce that by? 4. If you take a 4, if you divide both those by 4, you get 2x plus 1. And then you just throw that out. So here's your binomials. This times this. You're multiplying those two binomials. Now what are we going to do to finish the problem?
Make it equal 0.
Make each one equal 0. So your first thing says 4x plus 1 equals 0, and your other one says 2x plus 1 equals 0. Move the 1 over. You've got 4x is negative 1. Divide by 4, and what do we get? Negative 4th. Negative 1/4. That's it. That's one of your answers. And then this one, move the 1 over. 2x is negative 1. And x is negative 1/2. All right, so that is it. So on objective 110, you're going to get a quadratic equation. For the first time, it's a quadratic equation. If it's a trinomial, aside from the one crappy one that didn't work for us, you should be able to FOIL it into 2 binomials. If it's just 2 pieces, get them on the same side, and you can probably pull the x off of both those pieces. And that is objective 110. So let's go ahead and get started with that. Yep. Okay.